Welcome once again. I would like to thank you guys so much for all the feedback I've been receiving. You guys have been extremely supportive. Yeah, just want to thank you so much. And I'm gonna need one more thing from you guys. So I'm gonna need you to help me help you. By that I mean, please drop in any suggestion, comments. I just wanna have some feedback from you as we're gonna begin this entire process. And please excuse my setup. I just wanted to be in the comfort of my own space, so I had to improvise. And we'll begin with second term's context because I felt like that's when you guys got disadvantaged. So we're gonna start with term 2, go to term 3, and if we still have time, we'll go back to term 1. And yeah, so let's dive into the lesson. Okay, as I mentioned, we're gonna start with term 2's work. So this is the textbook that I'm using in case you are interested. So we're gonna start with heights and distances in 2 and 3 dimensions. So let's dive into it. Well, the first thing first that we're gonna do is remind ourselves of the sine, cosine, and area rule. Before we get into the sine, cosine, and area rule, I'm gonna need to make you understand how we name a triangle. Let's say we are given triangle AB, triangle ABC. So this triangle, we're naming the sides because we already have the angles. We have angle A, angle B, and angle C. So when we wanna find the sides, if we wanna find the sides, it means it's gonna be a small letter opposite the angle. So this is A, meaning we're gonna have a small letter A. This is the side, the name of the side. And opposite B is gonna be small letter B, opposite C will be a small letter. So dealing with the sine, cosine, and area rules is very important. It doesn't necessarily have to be A, B. It can be other alphabets, but it's gonna be still the same concepts working. So we're gonna start off with the sine rule. I know you're doing this, but we need a recap of it because, yeah. So we're gonna have, the sine rule says that A over sine angle A is equal to B over sine angle B, which is equal to C over sine angle C. Let's go back and draw a triangle because we work easier with visuals. Okay, so we have A, B, and C. And we have our A, our B, and our C. So what this means is this side over sine of this angle is equal to this side over sine of this angle, which is equal to this side over sine of this angle. So there's no, you can cram it, it's just a formula. Yeah, I hope we understand it. Now on to the cosine rule. So we're not going to prove these rules because you did them in grade 11. So what we're doing is just browsing through them and making our memories fresh. So the cosine rule, it states that a squared, this side, is equal to b squared plus c squared minus 2b times c over cos a. So the easiest way to remember it is just that the side you're looking for will always be the sum squared of those two other sides and minus 2 multiplication of those sides that you summed and cos of the angle that the side is opposite to. Not sure if I'm making sense, but let's say we were asked to look for b squared, for example. B squared is equal to, so we know that it's going to be the sum of the two other sides. So it's going to be the sum of a squared plus c squared minus 2 of this sides that we just summed. So it's going to be 2ac and times cos. The angle is always going to be the one that the side is opposite to. So in this case, it's going to be cos angle B. Okay, same thing goes for c squared. Sum of two other sides is going to be b squared plus a squared. Okay, or maybe we can, yeah, minus 2ab cos the angle that the side is opposite to, which is going to be cos angle C. Our final rule, which is the area rule. The area rule is, the formula is area of triangle ABC is equal to half BC times sine A. So we notice that they just take two sides and one angle. So the angle mustn't be related to these two sides. So we see that they use angle A and these two sides. So we can use the same principle when trying to find, when we are given another angle, say we're given angle B. So we're gonna try and use B. We're gonna go area of triangle ABC is equals to half. But now since we're given angle B, that means B will go to be our angle. And we can't use B again, so it means it's gonna be half times AC. Same goes when when we are given angle C rather. We're gonna say area of triangle ABC is equals to half, but we're given sine C, so which means the sides that we're gonna multiply are gonna be A and B because we can't use C again. Okay, there we have it for our last and final rule. I hope you guys understand, and once again, if you have any questions, just drop them in the comment section. Okay, so let's do a couple of examples. So in the first examples, we were given so much information, but what I normally suggest is that if you're given a three-dimensional shape, you just split it up. It makes things so much easier. And in the question, basically, we are asked to find the height of the giraffe. So the height of the giraffe is actually equal to AD. So the height of the giraffe is actually the same as this height. So we are basically looking for AD. But when we look at the triangle where AD is, we don't have so much information. So it's going to be impossible to work with this triangle currently. But then when we come to our second triangle, we have a lot of information, and which is very useful to us. So we're going to look what both these triangles have in common and try find some common ground of that and then work with that. So we can see that we have BD on this triangle and we have BD on this triangle as well, but we don't know the value. But with all the information given on this triangle, it means that we can find BD, okay? So we're going to use our sine rule. So we want to find BD. BD over sine, the opposite angle is angle C, is equal to DC, because we have the value of DC, so it's going to be smart for us to use it because we also have the value of the opposite angle, which is sine angle B. Okay, and then we just fill in the values that we already have from this. Okay, which is the same thing as BD is equals to 5 over sine 25 degrees times sine 28 degrees. So we just put the sine 28 degrees on the other side because we want to find BD. But when it goes to the other side, it becomes an inverse. So that's why we're going to multiply with sine 28 degrees BD. You just put that in your calculator and it should give you 5,554 meters. Do not forget your units, please, it's very important. Okay guys, so we found the value of BD, which was 5,554 meters, but we haven't answered the question yet because the question required us to find the value of AD. So now that we know the value of BD and we have the angle B, we can use SOHCAHTOA. So SOHCAHTOA is something that my best friend taught me in grade 10, and till today I haven't forgotten it. So it's our sine, cos, and tan. So it was sine is equals to the opposite of a hypotenuse, cos is equals to adjacent over hypotenuse, and tan is equals to opposite over adjacent. So yeah, as I mentioned, my best friend taught me this, and till this day I literally haven't forgotten it. So shout out to you, Dr. Nobile Mabuza. Yeah, here we go guys. So we used 10 because we wanted to find the opposite and we had the adjacent. So, and we had the ankle as well, so we just used this. You can take a look at it for a while, and yeah. So guys, this is it for today. We are through with the heights and distance in 2 and 3 dimensional. If you have any questions, anything that you need help with, assistance with, then you can just drop it in the comment section or Instagram me, Wendy Fasibego, Facebook, Wendy Fasibego, and I'll gladly help. Thank you so much.